In this video, we are going to look at the one-way multivariate analysis of variance, or one-way MANOVA, which is a test that you should use when you want to determine whether there are any differences between two or more groups of an independent categorical variable in terms of two or more outcome numerical variables. Here is the dataset that we are going to use to demonstrate this. You can get it from a link in the description of this video. In this dataset, we have got a total of 60 participants who are receiving 3 different drugs for treating hypertension. And after the treatment, measurements were done on 3 vitals, that is, systolic blood pressure was measured, diastolic blood pressure was also measured, and their heart rates are taken. So you want to assess whether there are differences in the effect of these drugs on the combined effect of the 3 outcome variables that are numeric. So in this case, a one-way MANOVA will work since we only have one independent categorical variable. If we had like 2 independent categorical variables against these outcomes, then that would be a 2-way MANOVA. To run a one-way MANOVA, simply go to Statistics, go to Linear Models and Related, and then you go to ANOVA MANOVA, then you choose MANOVA. You could also still get this same test by going to Statistics, go to Multivariate Analysis, and then you choose a MANOVA, then go to MANOVA. So let me go with the first option. Go to Statistics, Linear Models and Related, ANOVA MANOVA, and then select MANOVA here. In this dialog box, you specify the independent variables. Here we have systolic blood pressure, diastolic, and then heart rate. Those are the 3 dependent variables that we want to analyze together. Then in our model, we are going to specify our independent variable, which is drug type, and then we shall click OK. In this output, we have got the number of observations. There are 60. Then we have got a number of tests here. We have the Wilks Lambda, Pillai stress, and all these other 2 represented by their letters here for drug type, the respective statistics. They are all having degrees of freedom 2. F statistic is here at the respective degrees of freedom, and the p-values. You can see that all the p-values are statistically significant. In case there is disagreement between these values, then usually we go with the Wilks Lambda. With the statistically significant difference, we can see that drug type has got a statistically significant overall effect on the vitals after treatment. It tells you that at least one of the drugs differs from the other. However, this test does not tell us which of these drugs significantly differs from the others. Therefore, when we get these p-values that are statistically significant, we have to run the post hoc tests to tell us which drug or which category significantly differs from the others. Depending on the goal of your analysis, you can either choose to use multivariate contrasts or univariate contrasts. For multivariate contrasts, you want to determine which drug or which groups of my independent variable is significantly different from the others as far as the overall vitals are concerned. You're looking at all the outcome variables together. However, if you choose the univariate contrasts, you want them to show you which groups are significantly different from each other as far as each of the outcome variables is concerned. You're handling each outcome variable one at a time as you check which groups differ from the other. You can leave us a comment in the comment section if you want us to cover this in detail. That's how we can run a one-way MANOVA in Stata, and here is how we can present the results of our analysis. Feel free to customize it to the requirements of your institution. If you found this video useful, consider commenting, liking and subscribing to the channel so that you don't miss out any of our episodes. See you in the next video.